That rock here with some math. Let's talk about vector valued functions. So the example I have here is the function f whose input is t, and we have this scary looking notation here. We have the quantity double t but take off 1, so 1 less than twice t multiplied by that bold I, I'm going to talk about it in a minute, plus 4 times the t input, t squared. So you square the input and then you quadruple it, and that's multiplied by j. But I and j are just what's called the standard basis vectors for 2 space. So let's take a break before we'll come back to this. I promise it's not hard. But let's take a quick break and remind ourselves of what, or maybe introduce ourselves to this concept of a 2 space vector. So here's the Cartesian plane. The symbol for this is this weird called Math Euclid font, and you read it, you don't read it r squared, you say r2, but it's nothing more than a regular Cartesian plane or xy plane that you probably studied in your high school algebra class. And we have a x-axis and a y-axis, or 2 axes. Doesn't have to be x and y, but anyway. And a vector is nothing more than an ordered pair. A 2 space vector is nothing more than an ordered pair. So the ordered pair 4, 2 is a 2 space vector. So, and we all know how to plot the ordered pair. It's 4, 2. So you're used to writing it like so. That's the ordered pair. Well, it's also an ordered pair is a 2 space vector. So the notation may change. We might write it that way, or we may put these weird brackets, but that's all it is an ordered pair. Now, admittedly, if you've seen Despicable Me, you know that it has 2 key characteristics. One is called its magnitude, and the magnitude is nothing more than how far the vector is from the origin. So in this case, it's this distance there. That distance from the vector to the origin is called the magnitude. And then the direction is just the angle it forms with the positive x-axis. So notice this formed a little angle right here. That's called the direction, whatever that angle is. And we'll study that more in depth the next semester. But right now, I just need you to be familiar with what is a vector. And it's just nothing more than an ordered pair. A vector is an ordered pair. Now, when you take a class in linear algebra, you learn about bases of vector spaces. So the Cartesian plane represents a vector space, the collection of all the possible ordered pairs that we could get. And there are ways to generate them just from, if it's 2 space, just from 2 vectors that are not parallel. And the standard bases are I and j. And they are simply the vector 1, 0, which is that vector right there. If I were to draw the magnitude, there it would be. We would call that direction 0 because the angle it forms is 0 degrees. And then the other one is 0, 1. The direction is 90 degrees because it forms a right angle with the positive x-axis, and the magnitude is 1. But the thing that is important for us is we call this one I, and we use bold letters, and we call this one j. So when you see I and j, they're nothing more than the vectors 1, 0, and 0, 1. That's it. Okay, so we're going to go back to our problem, and when we see I and j, we're going to plug in 1, 0, and 0, 1. So here's our problem right here, and I'm going to plug in the vectors 1, 0, and 0, 1. So I have 1 less than double the input times vector I, which is 1, 0, plus quadruple the square of the input times vector j, which is 0, 1. Now, remember we're putting in some number for t, and so when you subtract, when you double that number and then subtract 1, you get a number. So this is nothing more than a number, this is nothing more than a number. And the way you scalar multiply vectors is you just multiply both components. So this gets multiplied by this, and that. So this vector is now 2t minus 1, oops, I don't know where that dot came from, comma 0, because anything times 0 is 0. And this vector over here is, well, I multiply that by 0 and I get 0, and I multiply 4t squared by 1 and I get 4t squared. Now, when you add vectors, it's also very simple. You just add the first component to the first component and the second component to the second component. So the first component is 2t minus 1 and over here, and then on the right it's 0, and you add 0 to something, you just get to something. So I just get 2t minus 1 plus 0, which is just 2t minus 1. And then I add the second component to the second component, it goes 0 plus 4t squared, which is just 4t squared. And so I see that this fancy notation just stands for this. But wait a minute, isn't this just here's my x and here's my y. We call this a vector valued function, but it's just a parameterized function. X is, x is 2t minus 1, and y is 4t squared. So vector value functions are nothing more than parameterized functions. You know, it's not a big deal. And this is easy to figure out what kind of function we're dealing with. I'm gonna add the 1 over. So I'll add this one over here and get x plus 1 is equal to 2t. And then I guess I'll divide by 2. So this x plus 1 divided by 2 is equal to t. So t is x plus 1 over 2. So I can come back to this y equation and I can plug that in for t. I can put x plus 1 over 2. And remember, it's being squared. So when you square a fraction, you square both the numerator and the denominator. So x plus 1 squared over 4. And it's being multiplied by this 4. So those 4's go away. And I have y equals x plus 1 squared. And so I see this is nothing more than a parabola. In fact, it's the parent parabola shifted to the left 1 unit because of the plus 1. So the graph of this vector valued function, once you take out the dynamic aspect of the parameter away, it's going to look just like this. Boom. But when I eliminated the parameter there, I kind of eliminated the dynamic sense that the t value gives us. So, you know, if I plug in 0 for t up here, I'll get -1, comma, and 0 there. 0 squared is 0 times 4 is 0. So I see this is the point, -1, 0 is the point at time 0. Okay? Math made simple, Simpson math.